Now the next topic is data types in Python. We know that in Python all values are stored in the form of objects. Now based on the type of value the objects can have, objects can be divided into two categories of data types: scalar data types and non-scalar data types. The objects of type int, float, complex, bool and none, these come under scalar data types, and the objects of type string, list, tuple, set and dictionary, these come under non-scalar data types. Now what is the difference between scalar and non-scalar data types? Firstly, when it comes to non-scalar data types, these objects will have an internal structure with multiple components. For example, if you take a string, let's say string ABC. So this is made up of multiple components called characters, right? And if you want, you can even access these characters individually. Similarly, let's take an example of list like this. Inside this, we have three different components, which are three different integer objects. And if we want, we can even access these elements separately. In the same way, tuple, set and dictionary, they also have some internal structure with multiple components. Now when it comes to scalar data types, these objects will have a single indivisible value. For example, if you take an integer 25, this 25 as a whole is a single value. It's not 2 and 5 separate. It is stored as a single value 25. Similarly, if you take a boolean value, let's say true, this true as a whole is a single value. It's not stored as separate characters like a string. So in this way, when it comes to scalar data types, these objects will have a single indivisible value. We will be discussing about non-scalar data types a bit later in the course. Each one of them requires a separate tutorial. And in this particular tutorial, we are going to focus on these 5 scalar data types. And in Python, we can use this type function to know the data type of any object, which is also nothing but the class to which an object belongs to. We discussed about this previously. All right. Now among scalar data types, we call int, float and complex as numerical data types because they obviously represent different numbers. When it comes to int data type, it is used to represent integer numbers. What is a good example of integer data we commonly use? For example, age. Age is represented as an integer. And as we discussed in the variables lecture, we use different variables to store the data temporarily so that we can reuse these variables whenever required. And while creating these variables, we have to give some meaningful names so that it is easy to understand what kind of data this variable is holding. For example, if I want to store this value 25, which represents age, I will give a meaningful variable name called age instead of a random name like a or x. Now, how does the relationship between variable and its value work? We have seen this already in the variables lecture. So basically what happens is when Python interpreter executes this instruction, it will create an integer object in memory with this value 25, and it will make this variable age a reference to this object. So the value is not directly stored inside this variable. In fact, the value is stored in the form of an object, and variable is only a reference to this object. Now whenever we use this variable anywhere in our program, Python interpreter uses that reference information and fetches that object. And we also discussed that variable itself will not have any data type. The type of the variable is nothing but the type of the value assigned to it. So here this 25 is an integer object. So the type of this variable age will be int. So when you try to print age and type of age, it will print 25, and type of age, it will print class int. Now let's see some more examples of integer data. So in PyCharm, let me create a new Python file. So let me give it name scalar data types. Let me also put a comment here, integers, and some of the examples can be age of a person. Let's say age is equal to 25, and some other examples can be the number of students in a class is an integer. So let's say batch size. let's say 100. So this is an example of integer. And let's say if we have an inventory, number of items in an inventory is also an integer. So number of items is equal to, let's say, 30, right? So these are some of the examples of integers. And when it comes to variable names, we have to give meaningful names and we have to follow snake case, which means all letters should be in lowercase. And if you have multiple words, you can separate with underscores. All right. Now here, let me try to print one of these variables. Let's say age, comma, let's also print type of age. Now if we try to run this program, right click, run scalar data types. So it prints 25 and type prints class int. Now let me tell you one interesting thing when it comes to integers in Python. Generally, when it comes to integers in other programming languages like Java, integers have a fixed size like 32 bits in Java, which means we can only use integers that can fit in 32-bit binary representation. We will talk about binary representation of integers in detail when we discuss bitwise operators. But what this means is that we have a limited range of integers we can use in our program. We have some other data types like long in Java to store bigger integers, but even that will have some limit. But when it comes to Python, there is no fixed size for integers, which means we can even use very large integers. As long as we have enough memory in our computer, Python will be able to accommodate that integer. Let's see one example as well. Let's say we have a variable a and let's assign a very big value to it, something like this. All right. Now let's take another variable b and let's also assign a very big value to it. Now let's try to find the sum of a and b. So let's try to print a plus b. Now if you try to run this program, you can see that it successfully computes the sum of these very big integers as well. And here we are using these variables like a and b because we are just simply seeing a random example. But when we solve some real-time problems, we have to use meaningful names, like these variable names like age, batch size, number of items, etc. But if you are simply testing out a few concepts, it's okay to use these kind of variables like a and b. Next we have float data type. Float data type is used to represent decimal point numbers, or you can also call them as floating point numbers. One good example of float data we generally use is the price of an item. For example, let's say the price of an item is $10.99. We can create this variable price and we can assign this value 10.99 to it. Now when you try to print price and type of price, it will print 10.99 and 10.99 is stored in the form of a float object. So when you print type of price, it will print class float. Now let's see some examples of float data we use. First example is price of an item. Let's say $10.99. We represent it as 10.99. Next example can be the grade of a student. Let's say we have a 4-point scale. The GPA could be something like 3.8. All right. Another example can be the temperature. Let's say temperature is around 22.7 degrees Celsius. So these are some of the examples of float data. So let me print one of them. Let me print price, comma, type of price. Now if you try to run this program, right click, run. So it will print 10.99, which is the value assigned to this variable, and type of this variable is nothing but the type of this value, which is a float object, right? So it will print class float. Now the last numerical data type is complex. We rarely use complex numbers in real-time programs, but just to give an example, so this is how we can represent a complex number. It will have a real part and an imaginary part, and we can represent it using this format 3 plus 4j. Here, just like usual, we're assigning this complex number to this variable cnum. So when you try to print this cnum comma type of cnum, it will print this value 3 plus 4j. And just like int and float, complex numbers are also stored in the form of an object. So these complex numbers belong to a class called complex. So when you try to print type cnum, it will print class complex. Let me add that example here. So let me create a variable cnum and let me assign the value 3 plus 4j. Now when you complete this line and when you want to press enter, sometimes you might get these kind of auto suggestions. So you can see that there is a list of auto suggestions and the first one in this list is GPA. Now if you try to press enter, it will add that GPA here. So we don't want that. So what we can do is, so let's say we typed 3 plus 4j and it is showing something like this. You can simply press escape. Then you can press enter. All right. Now let me print here cnum, comma, type of cnum. Now if we try to run this program, it will print 3 plus 4j and the data type will be complex. The next scalar data type we have is bool. So bool data type is used to represent boolean values. We only have two values in bool data type, which are true and false. Now these boolean values true and false are keywords in Python and not strings, which means we can't put them inside single quotes or double quotes. If we do that, they are considered as strings. A good example of usage of boolean values is email verification. Generally, when we create account in any website, it asks for email verification and you can access the website resources if we complete email verification. In that scenario, what we can do is we can create this kind of a variable email verified and we can assign true or false. So if the email verification is completed, the value can be true. If it is not, the value can be false. Now we can use this variable to write some boolean conditions based on which access is provided to the user. Here when we simply print this email verified and type of email verified, it prints this value true. And boolean values are stored in the form of objects of type bool, which means these objects belong to a class called bool. So type of email verified will give you class bool. Now let's see an example of usage of boolean values. So let me take the scenario of email verification we discussed. So let me create a variable email verified and let's say the user has completed the verification, so the value will be true. Now we can use this email verified status to write some conditional statements. And this is how we can do it using simple if-else statements. So don't worry about if-else syntaxes for now, we'll be discussing about them in detail. This is just to give you a basic idea. So when we write these kind of if statements, so we can specify some boolean condition here. So which means any expression which will evaluate to true or false. So it could be a single variable, or it could be a combination of multiple variables, values, and operators which will evaluate to a boolean value true or false. Now what we are basically specifying is, if this condition is true, we are asking Python to execute this instruction, which is to print you can access to the website. If not, if this condition is false, we are asking it to print please complete email verification to get access. Now here this email verified value is true, so it should print you can access to the website. Here it should be simply you can access the website. Let me correct it. All right. Now if we try to run this program, right click run. So it prints you can access the website. Now if email verified is false, then if we try to run this program, so it will print please complete email verification to get access. And here in this example, we are simply printing these messages, but when it comes to real-time applications, we might write some logic inside these if and else blocks. And also here we are directly specifying this email verified value as false, but in real time, it might be coming from some external source like database. All right. Now another example can be, let's say we have an inventory and we want to keep track of availability of a particular item. We can do it this way by creating a variable is item available and it can have value true or false. Now we can use this variable to write some conditional statements. Let's say there is some order, then we can write some conditional statement like if item is available, we can proceed with the order. We can write logic for it. If not, maybe we want to simply print item is not available. We can do something like that. Now let me simply print this variable is item available. Now you can realize that as soon as you start writing the name of any variable or function or class, it will show in these auto suggestions. So you can write till whatever you want comes at the top of the list, and once it is at the top of the list, you can simply press enter. This is especially useful when you have complex and big variable names or function names. And let me also print type of is item available. All right. Now if you try to run this, it will print true because this has value true and type is bool. Now a couple of things we need to be careful about. So here these values false or true, these are keywords, these are not strings. So you should not enclose them inside single quotes or double quotes. If we do that, this will be considered as a string, not a boolean value. So if you try to run this now, so you can see that type of is item available will now print str because this is a string now. Also one more thing is Python is case sensitive, which means when we write this keyword true or false, it has to be exactly in this way where the first letter is in uppercase and the rest of them will be in lowercase. But let's say instead of following this convention, you have used lowercase letter t. Then what happens? Let's try to run this program, and before even running, you can see something like this red underline, right? So if you hover over it, it says unresolved reference true, which means it is not able to understand what this true is. So if you try to run this program, so it throws a name error, true is not defined. So if we write true in this way, it will not identify this as a keyword true. Now when it is not a keyword, Python might think that this is name of something. It could be name of a variable, or it could be name of a function or a class or something. But we don't have any component with this name true, right? So that's why it says name true is not defined. And it also gives a suggestion, did you mean true? Which means it understands that probably by mistake you have not followed proper convention. So you have to follow this convention. First letter should be in uppercase. And don't get confused by seeing these quotes. We should not put this inside quotes. This error message is simply using these single quotes just to highlight these words. That's it. But when we write, we should not use any quotes. We should write something like this. Now it will be considered as a boolean value. Now if you try to run this program, so it works perfectly fine and it says type is bool. Now the last scalar data type is none. None is a special data type which has only one special value, which is none. And just like true and false, none is also a keyword, which means you can't put it inside quotes, and you also need to follow this convention of first letter in uppercase and rest of them in lowercase. None value is similar to null we find in other programming languages like Java. And when do we use this none value? We use it when there is no value for a particular field. To give an example, let's say we are trying to store the details of a customer, and let's say the customer has given the details of name, phone number, and let's say the customer has no email, right? Or the customer chose to not give the email. So in such cases, when we don't know the value, we can use this none value. Now if you try to print this variable email and type of email, it will print this none, which is this value. And just like any other object like int or float or boolean, none value is also stored in the form of an object of type none type, which means it belongs to a class called none type. So let me add that example here. So let's say email is equal to none. All right. Now let's print email, comma, type of email. Now if you try to run this program, so you can see it prints this value none and it belongs to a class none type. So with this, I hope you understood the 5 scalar data types: int, float, complex, bool, and none. Now all the scalar objects, which means objects of type int, float, complex, bool, and none, are immutable, which means once these objects are created, the object values can't be changed. Let's discuss about this immutability concept in the next tutorial. I'll see you there.